Okay, all right, I have Mike. Thank you. Thank you, folks, for coming to this session. We've already met our estimate. We were taking bets before we came in about how many people were going to stick around for the last session. But thank you for sticking it out. Thank you for coming in here. We'll try to entertain and inform you over the next 45 minutes. My name is Vamshidhar Kommineni. I'm a group product manager in the Azure Storage team. I have my colleague Saurabh here.
Hi, everyone.
And we'll be talking about AI applications and object storage. There's a lot of things, a lot of things have been said at the conference about AI already. I think what we hope to add is really kind of bring the data aspects to that conversation. You probably heard Satya saying in the keynote, AI isn't anything without the data behind it. So what we'll do here is we'll give you a little bit of a tour of training and fine-tuning with Azure Storage. We're actually really happy to talk about some of the ways in which OpenAI actually trained their foundation models and how they use our platform and the features we've built for them over the years that we're now able to release and have other customers use. We'll talk about enterprise AI applications, especially with the RAG pipelines and bringing your data in. And we have some fun new features that we've been playing with internally and wanted to show you and invite you to a private preview around bringing enterprise data to these AI services. So let's jump in. We have a busy talk, so I'll be going at a pretty rapid clip. We'll be happy to stick around here for questions and answers as long as you want after the talk, so until they kick us out because the conference has ended, but happy to be here. So let's talk a little bit before we go into the details. The broader Azure Storage platform, we build and ship the block storage services, Azure Disks, Azure Elastic SAN. We ship the file storage services, Azure Files, Azure NetApp Files, and we also ship the Azure Object Storage Services, Blob Storage, and Data Lake Storage. And all of these services are built by one engineering team on one common platform. And the platform is massive. It is the place where all unstructured data for all Azure services, most Microsoft services are stored. So if you use M365 Teams, you're using Azure Storage underneath the covers. If your kids or you play Xbox games and you have a cloud save game or your Xbox profile, you're using Azure Storage underneath the covers. If you use OpenAI or ChatGPT, you use Azure Storage underneath the covers. So overall, the system is huge, hundreds of trillions of objects, many, many exabytes of data. We ingress and egress, read and write, more than 150 exabytes of data each month. And that's a lot of transactions as well, more than 500 million transactions per second. So it's a massive platform. Most of what we're going to do today is zoom in on object storage. That's sort of the canonical storage of cloud storage. And it's what is prevalently used for AI applications or AI training and fine-tuning. So let's kind of give you a little bit of an overview of that again. How many of you are familiar with Azure Blob Storage? OK, almost all of you. Wonderful. So I'm not going to spend too much time explaining the basics. I'll jump right in. All of you know about the REST API and all of the SDKs and tools we have on top of that. That's what we call our common blob storage foundation. Internally, we call it FNS for flat namespace. A few years ago, 2018, we released what we call Data Lake Storage or Data Lake Storage Gen 2. That's really built on this additional layer called the hierarchical namespace or HNS. That's what gives you folder structure, folder and level ACLs. So that is what the other protocols are built on. So if you're using blob storage and you use the Data Lake Storage API or used it with Databricks or other analytics engines, you're using that HNS layer. If you use Blob NFS v3, you're using that if you use the SFTP endpoint. But all of these are multi-protocol. They interoperate, and they allow you to build large data lakes. So as we jump into this talk, we're going to kind of touch on what kinds of features are interesting for AI inside blob storage. What I want to start with, though, is play a short video. It's about 2 minutes long with OpenAI talking about what they do with blob storage. So let's play that video.
At OpenAI, we have to move really fast to stay on the forefront of AI research. We constantly need to process more and more data more and more quickly. My name is 𝗦𝗽𝗲𝗀𝗀, and I'm a member of technical staff at OpenAI, and I am the manager of the supercomputing storage team. In order to train the world's best AI models, we have to ingest vast amounts of data into our data pipelines. Azure Blob Storage scaled accounts have really helped us grow our data pool without growing our operational complexity, and that lets us use blob storage throughout our stack, not just for training the large models directly, but also for all data pre-processing, data storage. Even our customer-facing applications like ChatGPT uses Azure Blob Storage for uploads from the customer, whether that's documents or images for processing by the large language model itself, or outputs from things like DALL-E, where it generates images for the customer. Those all go into Azure Blob Storage. Being able to scale our storage is really essential. As storage systems grow, very often there are performance bottlenecks that cause you to break them up into pieces and then have to manage individually. Having scaled accounts has let us not have to build any of that infrastructure ourselves and just rely on Microsoft's solution. The Azure storage team has really partnered quite deeply with us and support us in our scaling the system from smaller scales to exascale.
Yeah, so that's a nice little kind of brief overview. And Sam in that video talked about scaled accounts and a couple of other things. So we'll kind of touch on those as we go along. One of the pictures he showed in that video was this picture, right? It's an AI training pipeline, kind of a storage-centric view of that, where we are in a storage talk. And really the steps here are around getting large volumes of raw data. That's the data collection ingestion step. There's usually sort of what looks very familiar to an analytics person, with a Spark pipeline or Databricks or something else where you're doing data cleaning and data preparation. So you have this data that's ready then to be converted into training data. That training data is fed into these large GPU clusters. And one of the things that really happens there in terms of a storage challenge is checkpointing, which is state snapshotting of the entire GPU cluster into storage. That's a very high throughput operation. If there's failures during the runs, those checkpoints have to be read back to restart the training. These training runs can be months long. So this kind of process of checkpointing every few minutes and being able to restore is very, very important. Those checkpoints are also retained for a long time. And finally, you use all of that to kind of build and publish the base model that we all use. And you can run inferencing queries like ChatGPT is an inferencing app against those base models. This is great for a foundation model builder, but a lot of what all of us will be doing is more like fine-tuning, right? We have domain-specific data, or we have our enterprise-specific data. The pipeline looks very similar, right? It's just that the scale of data is smaller. So you still bring in your data, you still prepare it, you clean it, you train but you start with your base model, and then you end up with a fine-tuned model that you're able to use for your domain, let's say medical imaging research or something like that, where you're training with different sets. So these two things are useful for us to show that the learning we had in these much larger training, we're able to bring those features, those capabilities down for everybody's use. In fact, when you're doing fine-tuning today in Azure, some of this stuff is baked right in. So AI Foundry, which is the new name for the AI Studio, has integration with blob storage. When you try to go in and say, hey, I want to fine-tune a model, in this case, GPT-4o, you get this prompt of saying, hey, do you want to add your data in Azure Blob Storage? Right? So that's really nicely well integrated, and something that you may run into as you go and build your, fine-tune your models and build things out. So let's talk a little bit about the storage requirements, though, and what led us to building some of the features we built here for OpenAI and other customers. We talked about ingestion, being able to bring in large quantities of data, and we'll talk about that a little more towards the end of the talk. This integration with analytics pipeline, that multi-protocol view I showed you at the beginning is really essential for that, because the integration with analytics pipelines, whether it's kind of older style Hadoop pipelines or newer style Spark pipelines, is much better if you have these file and folder level semantics and are able to do stuff with it. The GPU node local access, being able to have kind of the ability to access for data engineers, data scientists, data in object storage as if it were just your local file system is crucial. We talked about checkpointing already, and we'll zoom in a little bit into those two. And lastly, you do need data management. Like, it's a common problem for all customers with large amounts of data, but in this AI space, managing this data, knowing what you're doing with it, retention of that data for things like AI model lineage and governance is super important. So those are some of the things we've been thinking about across the team. Let's talk about features we've built for a couple of these. So for checkpointing, throughput is everything. It's all about, we call it internally sort of speeds and feeds, right? You've got to have the fundamentals of the system be rock solid, be very scalable. One of the big innovations we've launched over the last few years, and this is something we've been on a journey on in our platform for many years, is called scaled accounts. These are largely transparent to you. When you start pushing our system to the limits that we publish, we automatically move you into these scaled accounts. It's not something you have to go choose or do anything with. You get these automatically at high throughput, high TPS, high amounts of capacity. And the idea is essentially to take your storage and spread it across these storage clusters in an entire region. So we have regions where we have tens to hundreds of exabytes of capacity, lots of throughput, lots of networking air across many zones. And we're able to dynamically and intelligently spread your data across those. So if you have a smaller data set with lots of throughput, we can take care of that. If you have tens of petabytes of data, we can spread that out. You really don't have to worry about it. And that was kind of what Sam was talking about in his talk, where he said, hey, scaled accounts allow us to not worry about that at all. These are things that are in production now. Something like a third of our customer data is already stored on these scaled accounts at the higher end. And customers are using it especially over the last couple of years, and has really enabled us to scale up to these AI workloads. The other thing that we've done here, which has been really great, is a fuse driver called Blob Fuse 2. If any of you are familiar with the older Blob Fuse, it's been rewritten completely. We encourage you to give the new one a try. And the idea here is pretty straightforward. It is allowing you to use blob storage as a mount point on your VM, on your Linux VM or your pod, and just be able to work with it as if it were a local file system. Of course, there's a lot of interesting smarts behind that in terms of allowing you to get scale and throughput, again, allowing you to leverage all of that throughput that blob storage can give you. But let's jump in first and take a quick look at a demo. Go ahead, Saurabh.
Thank you, Vamshi. Now, on the left here, we have connected to a D96 VM that has 35 gigabits per second of network bandwidth overall. And on the right, what you see here is a blob container, right, which has a bunch of files here. What we're going to do now is to connect this blob container as a mount point to this VM. So first, let's check, and we're going to mount it in this folder called blob fuse mount. First, let's check if this folder is empty. It is empty. Now we're going to run a mount command quickly and ensure that we are able to sort of mount this container on the right to this VM. All right, that was the command that we just ran, blob fuse to mount. We'll now go into this folder and run ls again. And so now what you see on the left is the same set of files that you have on the right. And so you've basically been able to connect to that blob storage account very quickly. And not just that, you can actually perform operations. So I can say hello from blob fuse 2 and pipe it to hello.txt. And out here as well, in this container, I should be able to see the same file pop up. There is hello.txt. And it says hello from blob fuse 2. So this is awesome. We are able to connect the file system. We are able to talk to it as if it were a local file system on the VM. But how much can we do in terms of throughput and performance? So what we're going to do now is, on the left, we're going to try reading two 50 gigabit files. And we are going to be able to then see what is happening on the network to see if we are able to max out the network bandwidth on the VM or not. So on the right, I have this application called nload, which is scaled up to 35 gigabytes per second. And now I'm going to be able to see, if I run this, what is happening on the incoming and outgoing side of this VM in terms of network. So let's go and start reading these files. I'm going to just quickly pull up the command here. There we go. And the moment I actually execute that command, you can see that nload lights up on the right. And you can see the instantaneous speed actually going to almost 35 gigabits per second. So that's pretty awesome. And what is happening behind the scenes is BlobFuse2 is actually doing a bunch of prefetching and caching of the file that is being read. And that is allowing us to not only take advantage of the throughput or the network bandwidth in the VM, but also being able to serve the application, which is running on the left, with that data very, very quickly. So just like that, in 30 seconds, we were able to read 100 gigabytes worth of data. That's pretty powerful. And now to just show how caching really helps, especially in the case of fine-tuning when you have static data that you want to reuse again, caches are really helpful. I'm reading the same files again, but this time you don't see any network coming in from the top portion of the right screen, and because there is nothing actually coming from the network. It's actually being served from the cache, the file cache that is actually there on the VM. So that's pretty powerful, and we were able to read the same set of files in just 12 seconds. But not just read, we are able to write these files very quickly as well. So let's do that. Let's go ahead and write 2 files, 2 20 gigabyte files. And this time when I do this, I'm able to see the outgoing portion of the right screen essentially light up and reach that max throughput of 35 gigabits per second. So that's pretty powerful. We are able to max out the throughput of the VM. So it's not essentially the storage that is the limit here. To Vamshi's point, we're able to scale that throughput pretty high enough, and we can essentially max out and get great performance with BlobFuse2. I'll give it over to Vamshi to talk to some of the optimizations that have enabled this performance to happen.
Absolutely. No, that's a great demo because it really shows you the ability to saturate the entire NIC on a VM with the fairly simple file system commands that we're running. And so your application doesn't really have to change. A data engineer, a data scientist working with their data can just treat this as a file system. And that driver, the BlobFuse driver, is doing a few things. It's doing all of the proxying of the I/O commands to REST API calls. But as Saurabh pointed out, it's also doing caching. And we have 2 kinds of caching. We have the traditional file caching. We'll get the whole file if the cache is large enough, and you can configure the cache. Some of our GPU VMs have up to 30 terabytes of local NVMe, so you can get a pretty large cache going for your training data sets and things like that. But we also have something pretty cool that we added recently called block cache. So the idea here is we can do a streaming sort of cache. As you start reading a file, the driver is smart enough to know you're probably going to sequentially read through the rest of the file. So it will go ahead and get cache ahead blocks from that file. So your perceived performance as an application is way better than what you're going to get over the NIC because we have parallelized all of our reads. We're going and getting chunks of the file in. So all of this is happening completely transparent to the application. You can go configure these caches so make sure it's using resources fairly versus other things happening on that VM. But once you do that, again, your team of data scientists, data engineers don't have to worry about the infrastructure behind this. They just know that they have a super performant system. How performant is this system? Just to kind of push the limits here, we ran some tests. So what we did here was started a huge test in one of our regions. We were really only gated by how many free cores we could get before they yelled at us. So we got up to about 17,000 cores. Working on data set about 2 petabytes. Saurabh was talking about 50 gig, 20 gig files. We said, hey, let's push the limits a little bit more. Let's take a little bit larger data set. What we were able to see empirically was pretty amazing. Right? Over 1 terabyte a second of writes from these pods into blob storage and nearly 2 terabytes a second of read. Right? And we could have gone higher. Right? That's the cool thing. If we had more cores to load the system more, we really could have gone higher. So that's the power of all of these things put together, the scaled accounts as well as BlobFuse. This is exactly the same tech OpenAI was using, is using under the covers. And all of this is available to any customer using blob storage today completely transparently. putting all of this together, and let's wrap up the training and fine-tuning section, you need high scale. We're able to give you any number of petabytes of data, terabits per second of read and write throughput. You really want to have transparent access to this data without having to program to it, et cetera. BlobFuse 2 takes care of that. Multi-protocol access allows you to have all of the data cleaning and data prep happen and then just be able to move that data into a training phase without really having to copy your data around between storage systems. Data management, we haven't touched on too much here, but you have some really great features like blob index tags, last access time-based tiering down. And you really can make this very, very cost-effective because this is regular blob storage underneath the covers. You have the hot, cool, cold tiers. You even have the offline storage with archive storage. So if you have large training sets or large checkpoints and you're like, look, I really need to save money on this, all of the existing functionality with lifecycle management just works. So let's switch gears a little bit and talk about something that's probably even more top of mind for folks. How do you go build AI applications? And one of the things that people have been doing, there's kind of a few different techniques here. We talked about fine-tuning, of course, taking a base domain, a model like a GPT-4o or a Llama 3 or something like that, and learning new skills. So you put in domain-specific data. You kind of think of that as learning, helping the model learn new skills, like the medical imaging example we're using. You also, of course, can do prompt engineering. That's a very common technique, and people are doing that on the left. But one technique that's become very prevalent is learning new facts. It's really providing more context along with your query, inline to the LLM and being able to leverage that. That is something that requires some interesting processing techniques and storage challenges there as well. And this is the place where you really bring in, whether it's fine-tuning or RAG, you really bring in your data, your company's data, your domain data. And with multimodality, you're bringing in increasingly not just textual data, but you're bringing in video, images, PDFs. And I think there's going to be a huge explosion of use cases once these multimodal models, they're still very nascent, become prevalent over the next couple of years. And the data challenges are what we've been thinking about and working with customers, with all of you on. So Saurabh, I'll turn it over to you to talk about RAG and kind of talk through this.
Thank you, Vamshi. So retrieval augmented generation, as Vamshi was saying, provides in-context knowledge and helps combine reasoning from the base LLM with the knowledge that comes from the data sources that are part of your knowledge base. And as it comes to the pipeline itself, if you look at the storage-centric view of this pipeline, again, if you look on the left, it's similar to training, fine-tuning, where there is ingestion and data preparation. But what is different is you want to break down your data source into specific and very, very targeted chunks, because that is exactly what you would retrieve with the limited context window that every LLM has. And so you want to use that context window very, very judiciously, and these chunks allow you to do that. What really happens when a query comes in is a vector DB gets involved, and that's where the vectors from these chunks are stored, and these vectors are called embeddings, so we generate those embeddings and store them in the vector DB. And when a retrieval happens during a query, you are basically checking the semantic similarity with the vector representation of the query and your knowledge base, and then you're augmenting that knowledge base through prompt augmentation, and then finally getting a response. So there is a lot of interaction with the unstructured data storage platform, which is where all these multimodal images, videos, and PDFs are stored, and that brings us to the very core requirements of this system. So on one hand, of course, we need to be able to ingest a lot of this data quickly. That's very important, and we'll talk more about that as we go along. But more importantly, we need low latency access to that data. Imagine you ask a question, and you are waiting for the response because now your LLM is basically getting that data from your object storage platform. You need low latency access so you can get quick responses when such retrieval happens. And of course, you need integration with vector DB because all these indexes that are there in your object storage need to talk to the vector DB to generate new embeddings. And as these data sources update, you want these indexes and these vectors to be updated as well. So that freshness is a very important aspect of these requirements. And finally, we don't want a user that doesn't have access to the underlying data to have access to the response that references that data. So security is a super, super important priority. And blob storage essentially offers a bunch of these in the form of Entra ID and ABAC. We'll talk about that in a bit as well. So summarizing what blob storage has today that you can use to be able to enable RAG very effectively on our platform, multi-protocol, which Vamshi talked about, allows you to get that data, process it through various analytic engines. Low latency access is something that we enable with a feature called Premium Blob Storage. It's a premium SKU of blob storage. It's been around for a while, since 2019. It's backed by SSD and allows for consistent low latency access, super critical for that quick retrieval when you're deploying a RAG application. VectorDB integration, I'm guessing a lot of you have interacted with AI search. It's quite deeply integrated with AI search. We'll see that in a demo as well. But not just AI search. If you pick up any open source vector databases or databases like Pinecone as well, we support multiple indexes and have the SDKs and tools that are required to interact with these open source vector databases as well. In terms of freshness, we have a unique feature called change feed. And change feed allows you to get an ordered, guaranteed, and consistent, an atomic set of changes that you can process together. And as you do that, you can update your vector index for fresh responses. Of course, change notifications is also another aspect which has been built into blob storage for a while. And finally, for security, blob storage has integration with Entra ID and RBAC. And in addition to that, we provide something called ABAC, which is attribute-based access control, that allows you to take specific aspects or attributes of an environment, such as a project, a finance project or a marketing project, and give people access to files just in those environments so that you don't have cross-department access of data and give privacy a threat, right? So that is something that we are able to sort of do very effectively with blob storage. Now let's see all of this in action. So I'll switch to my demo screen. All right. Hopefully, folks at the back can see everything. Let's talk about how well blob storage is integrated into our AI services ecosystem. If you go to Azure AI Foundry and you want to add your own data or your own knowledge base out here in Data Plus Indexes, when you add new data, you can actually see blob storage as the primary source from where you can add these data assets. And not just that, if you want to add an index, even for that index, the data source that you select could be blob storage as well. So right from Azure AI Foundry, you're able to interact with blob storage very easily. Not just that, if you go to Machine Learning Studio, where you want to run your data pipelines and train and fine-tune models, not just Gen AI models, but even other models that you like, you can actually create a data store. And even here, the data store type is Azure Blob Storage by default. So that allows you to pick the data very quickly and integrate that into machine learning pipelines very easily. And my favorite is the chat playground. This is one of the areas in the AI Foundry experiences where a lot of developers start experimenting and evaluating their RAG pipelines and their models. And even here, you get the option to add your data. And when you add a data source, you essentially see blob storage here as well. So when you select blob storage, you provide a blob storage account, you provide a container, and an AI search resource which has your vector index. Talking about AI search, if I go to AI search, which is right here, they have import and vectorized data, which is a single-shot approach to not just creating an index, but also vectorizing that index and generating those embeddings. And even out here, when I do import and vectorized data, I see blob storage right here as well to be able to set up that data connection. So net-net, all of these AI services are able to access, read, write data to blob storage extremely easily, and all of this is available today for you to use with your unstructured data. Now let's go a step further and try something interesting. I have this blob storage account here, and inside this, I have a bunch of facts about Chicago. And I thought, it's been a great Ignite. Let's learn more about Chicago. So I pulled up a bunch of facts about Chicago and put them in a PDF. And I tried hooking up an application so that I can talk to these data sources. So this is my chat playground, where I've essentially added the index from my AI search. And that has all my Chicago facts in here. And now I'm going to go type a query. Give me the list of the oldest and best deep dish pizza places in Chicago. So let's see what it comes up with. OK. It's getting Pizzeria Uno, which is established in 1943. All our favorite places. I'm not going to debate on the order here. I'm sure we all have our favorites. But the references here are coming from my blob storage account that I just showed you. So Chicago blob fact 0 is right here. And if I download this file, I can actually see that it's showing me the same set of facts that we see here, right? So this is grounded really well. And this just goes to show how quickly we were able to hook up a system with Azure Blob Storage and build a chat application very quickly. So let's go back to our deck and talk a bit further about what we just did. We essentially took a bunch of PDF files, we cleansed them, we chunked them through integrated vectorization, added them to AI search, and then inferenced them using Azure AI Foundry and GPT-4o. Now, one of the important things that is really critical is to bring enterprise data into the system. I was able to get those PDF files, but we're not talking about a couple of PDFs. We're talking about massive terabytes to petabytes of data. How do we do that? So I'll give it over to Vamshi to talk a bit more about that topic.
Thanks, Saurabh. So this challenge of bringing data in, the canonical traditional way has been migration, right? You move your data. We've built a lot of different migration tools over the years to make this easy. Of course, you have Azure Migrate for your IaaS servers. You have your database migration. The things that I would look at the bottom, if you have data on your NAS or SAN, there's a couple of different ways of doing this. First, probably your first stop is Azure Storage Mover. If you have enough network connectivity, you go ahead and bring data in through the Azure Storage Mover service. It's a new service, new-ish. It's been in GA for a little over a year and a half now. And that will really help you kind of discover your data, assess your data, run a job, and do sort of this good low downtime migration of data as you need to. If there are data sources or destinations that the Storage Mover doesn't cover, we have the Storage Migration Program. So we've partnered with a number of leading data migration ISVs, like Comprise, Data Dynamics, and Cirrus Data, to bring that data into Azure Storage free of cost for customers. So that's something you can search for, the Azure Storage Migration Program, and find and use those ISVs from the marketplace. We also have our data box. So if you don't have enough network connectivity, or you have a very hybrid sort of data generation scenarios where your data is offsite somewhere, you need to bring it in. For many years now, since about 2017, 2018, we've had the Azure Data Box. We are announcing at this conference a new version of the data box as well. This is all flash now, looks the same as the old one did, but all flash, completely new internals. And the really cool thing about it is because we're putting flash in here and we can make it very dense, we can pack up to half an petabyte of data in a single box. Right? So if you have a lot of data being generated somewhere and you bring it in, order one of these, it's 50 pounds, it'll come in, you can fill it up, send it back to us, and we'll have your data ready to go. But bringing data in, migrating data in, isn't always easy, right? On this one side, you have all this nice integration that Saurabh showed you between all the Azure AI services and object storage, but there's the reality of where all your data is. It might be in different services in Azure, on-premises, might be in a NetApp, might be in an Isilon, and it might be in different cloud providers too. This data is hard to filter, right? You don't know a priori before building applications or fine-tuning what you actually need to migrate. You might want to migrate a subset, not the entire data estate, right? You might have all of this heterogeneous data sources. You want an easier way to just test things out. And the data might actually have residency or sovereignty requirements where you're not allowed to store it. In another place, you have to access it where that data was generated and where it's stored. So how do we kind of go solve all of these problems? Let's actually jump right into a demo to show you this and we'll come back and talk about what we showed you. But this is something we've been working on internally. It's going into private preview, and we're very pleased to show you this for the first time. Go ahead, Saurabh.
All right, I'm super excited about this. I'll be going back to Seattle and trying to make some deep dish pizza. I never get it right. So I wanted to know what is the secret ingredient for flavorful and fluffy, and Vamshi and I had a debate about fluffy. I did actually have the pizza, and the crust is tight from outside, crusty from outside, but fluffy from inside. So what is the secret ingredient for flavorful and fluffy deep dish pizza? Let's run this query. I did actually run this before, because I want to focus on what is missing. And so what it says is that there is a secret flavor enhancer. But it says that the secret flavor enhancer is not disclosed in this document. This is the same kind of problem where you have data sources elsewhere. And so now I have this data source which is actually sitting on an ONTAP on-premises, NetApp ONTAP on-premises device. And I want to bring that data over and essentially be able to inference with that data. We've not been able to do that before until now. So let me go and show you something quite interesting. Let's go to my storage container. This is the storage container where there is all my native data. But inside the storage account now, we have something new cooking, for the lack of a better phrase here. But storage connectors. This is the first time we are showing this at Ignite, and we'll be launching private preview for storage connectors soon. But storage connectors is essentially what allows you to easily connect to your data wherever it resides. And so you can connect, view, and stream your data from various sources, whether they are in Azure, in other services, or in fact even on premises. So let's try this out. Let's create a new storage connector and see if we can connect up our on-premises, on-tap NetApp device to this blob storage account. So we'll just give this connector a name. You're going to select NetApp ONTAP. Give these some inputs, and out here, we just add the secret access key. And then we have this nifty button called Test Connection that allows us to test if we are able to reach into that device. So test connection succeeded. Awesome. And now, because we are not going to have the data physically in the blob storage account, it's actually physically living in an ONTAP on-prem device, we are going to talk to it through a virtual container. And so I'm going to create a virtual container. This is my virtual container. I'm going to hit OK here. So there's my connector. It says the data source type is NetApp ONTAP. And now when I go to my containers, I see another container here. It says ONTAP AZ storage. And you see a different icon here. This is a virtual container. When I click on it, I can actually see the files inside my NetApp ONTAP on-premises device. And I did not essentially move or copy any data, and these files just magically show up here. Now, we can go back to AI search, and we need to sort of update our index because we were using that index in our previous chat playground experiment. So let's go to AI search now. Let's do import and vectorize data. Go to blob storage. And now here is the interesting part. When I go to my storage account, not only can I see the original native container here, but I see even the virtual ONTAP AZ storage container. That's pretty cool, because now I can provide this container exactly as I would do a native blob storage container and have it completely indexed. So I've actually created the index already for this, and I've done that in my AI search service. So you see these two data sources. There is the native blob data source and the ONTAP data source right here. Now let's go back to our chat playground and ask this question again. What is the secret ingredient for flavorful and fluffy deep dish pizza? OK, so we get the secret ingredient for creating flavorful and fluffy deep dish pizza is semolina flour. How many of you knew this? Even I didn't. Even I didn't. So this is awesome. And the best part is the references. Well, there you go. The references are actually coming from blogs ONTAP 1 PDF. So that's actually coming from my remote and on-premises ONTAP device. That's pretty cool. Now, not only can I do this with my NetApp ONTAP device, I can actually also do this with my other Azure services. So I can, for example, add all these data source types, but I can also add Azure NetApp files. Right? I can add Azure NetApp files, NetApp ONTAP, Dell 1FS, AWS S3, and we'll keep adding these data sources as we go along. But what's interesting is I can do the same thing for an ANF volume as well. Similarly, test connection. Connection succeeds. I can add a virtual container. And when I hit OK, I now have two connectors. of different data source types, and I can essentially go and search things across all of these sources. So let's just do that. Let's do something fun and see if we can try out a different query. We're going to say, summarize everything about Chicago, especially its deep dish pizza legacy, restaurants, evolution, with as many references as possible, and let's run this query. Well, it's taking a bit of time because of the network. I had run this query before, and so right here, I have this very detailed output for the same query. But what is the interesting part is the references. I have 11 references. First reference comes from ANF. The second one comes from 𝗲𝗏1FS. That's pretty interesting. How did that happen? We'll talk about that in a bit. The third one comes from Blob, the native Blob data source that we have. And so you see all these references are being pulled from different sources. How did we do that? Well, I hooked the index on this chat playground to a storage account where I have all these connectors. These connectors are pulling data from NetApp files, S3, 𝗲𝗏1FS, and ONTAP. And now when I go to my containers, check this out, I have been able to logically unify all these virtual containers in the single storage account. And I can click into these. I can browse them as if these files were essentially natively here on my blob storage account. This is the set of files from my ANF volume. I can go back, and I can click into AWS. These are the files that I have in my AWS S3 account. And I can do this for ONTAP. I can do this for Dell. Remember the file that we just saw, guides 𝗲𝗏1FS? That was coming from here. So this is really awesome. Not only have I been able to logically unify everything into a single blob storage account, but because I'm accessing it as if these files were on blob storage, every other service in Azure, AI services or IoT or streaming services that know how to talk to blob storage can talk to my remote data without any boundaries. So that's pretty cool. And yeah, Vamshi, over to you.
Yeah, thanks. If you couldn't tell from Saurabh, we're very excited about this feature. We think this really starts to bring all the data anywhere in the world to Azure's AI services for you to build these applications. So what we did here is really build those storage connector technology, just abstract this connectivity, and allow you to also unify all these data sources into one logical place. So you don't have to have all of these things of, oh my gosh, where are these data silos? What do I copy? What do I do? Did I mess it up? Nope, just get your data from wherever it is, connect it in, run those experiments, unlock value for your data scientists and data engineers, and get going. You're able to index and access this data no matter where it is. And when you're ready, you can use the same technology to migrate that data, so it's really, really seamless and easy for you. So this is something that we are working with a number of different partners. We've already sort of tested and worked with these partners on the screen now, and we'll add more partners as we go through the preview process. This is available now for a private preview. We'll be signing folks up and letting them into the preview. So if you're interested in this, if you think this is something you want to try, something you want to give us feedback on, please take a picture of that, or we have a very wordy little URL at the bottom. So just let us know. We're excited to bring it to you. We'd love for you to try it out and give us feedback and help us improve it. So let's wrap up this talk. We're almost at the end, right? So Azure Storage is great for building AI applications. On the training and fine-tuning side, if we can handle OpenAI, we can handle everybody else, right? We have this great connectivity with analytics engines for cleaning and preparing your data. You have fantastic scalable throughput with that cloud native, with a mount point type access to your cloud storage. You have all of this beautiful integration with Azure AI Services you just saw, but you can also plug in your own LangChain and custom ways of doing RAG. You have great performance for RAG pipelines with Premium Blob Storage, something that's been GA for many years now and is very useful in this scenario. We also have a great way of dealing with data freshness in all these hybrid scenarios where you have data flowing in constantly and you need to update your models around that. All of this is built on that common blob foundation that we talked about. Very cost-effective storage, great HADR functionality, really good focus on security with the RBAC and ABAC features, and really good data management. To put this all together, we'd love for you to try this out, see what works, what doesn't work. Again, this is something very collaborative. We're learning about what use cases work and don't work in AI applications. We would love to hear from you. So a couple of calls to action here. Azure Storage feedback at Microsoft.com is our team feedback alias. There's always a bunch of us PMs and developers monitoring that. So if you think of something, you're trying something, shoot us an email. We're happy to respond and call you or talk to you. Last thing, there's a couple of other sessions. Of course, we have the last session of the last day, so they're all done, but they'll be recorded and available. Do send us an Ignite eval. Tell them if you would have liked to see this session earlier in the week next time. So this is where we are, and that's all we have. So we're right on time. Thank you again, folks. We'll be here to answer questions. Thank you really for being here all the way till the end. Appreciate y'all.
Thank you so much.
Thanks.